in a really strange world between engineering and fashion and other things, so a lot of pressure on me always to look good and make good code at the same time. I'm talking about migrations today. Since we're late in the afternoon, one little audience participation. Who has migrated something from some place to some other place? Content related, ideally. Yeah, all right. Who enjoyed that? Okay, a couple. Well, that's great. I can promise you all of you will do it again at some point as well. It's interesting, when I started looking into at Vogue, we had to do a pretty big migration. We had an internal CMS that we were spinning up, and we wanted to leverage that across the entire org. And so each of our brands had to go through and do some migration. When I was studying our level of effort and trying to figure out how to build a strategy for this, I didn't find much material out there written about how to migrate effectively. So hopefully I'm going to share a few of my best learnings from our process. But yeah, basically migrating is usually pretty terrible. It's really just an exercise in kind of organizing fire. It's not going to be great. There's going to be bad stuff regardless. So traditionally, when you migrate stuff, you got sort of big red button moment. You line everything up, you get everybody ready to go, you push a button, and usually you can't undo that. Frequently it's tied to specific business initiatives. You actually have to take this live for some new website you're launching. So rolling back is very hard, and it's kind of all at once. You're launching a new theme, you're launching the data in the new source, new API, all sorts of stuff that's really hard to, again, undo if necessary. So let's talk about a lean migration. We've got to use all the right vocabulary. So we're talking about a minimum viable migration. We're talking about continuous migration, all that type of stuff. So minimum viable, like, is there any content that you can just staticize and leave somewhere where it is, not put it in the new system? Continuous migration. Things are not in production until they're in production. They are not done until they're done. You will hit errors, you will hit situations, and when you roll everything out at once, you will find them all at once, and that could be a big issue. So we really want to do a gradual rollout, is the point. So I tried to do math, and I'm not good at math, so this may or may not prove what I'm trying to say. So the basic concept is that there's kind of 3 error camps that I was able to find. Kind of the front-end errors. I heard it very well said in New York at a GraphQL meetup, the concept of property whack-a-mole. Cannot get this of undefined or of null or whatever. So all sorts of errors due to data, missed expectations. API field mapping. If you don't get the names of something right, if your consumer uses that field wrong, they think it means a different thing, you can have some errors there. As well as the actual data as it migrates. There's encoding concerns, from Unicode issues to HTML versus various encoding situations that can affect you. As well as the actual number of entity types. So these are compounding. As you add an error in one case, it can affect the rest. For instance, if you don't get one of your contributors moving properly, maybe their entire content also doesn't move. Or if it does, it moves with errors. It doesn't have attribution. So these all affect each other pretty significantly. I tried to do just a little bit of numbers behind this. So let's say 99% success rate, 1% error rate in each of those 3 categories multiplied by this 7 actually gives us close to a 21% total error rate. So this can be a really big deal. This is why we want to separate these things out and reduce our risk. Avoiding all types of errors, including serval errors, the dreaded serval error, 500. So plan your migration. Start with enumeration. Figure out what you're actually doing. Who are your consumers? Do you have iOS apps out there? Do you have a website? Do you have a VR app that you need to support with your content? What is the entire outlay of your system? What entities do you have? We'll look at some of the basic categories of entities on another slide, but content items, images, authors, whatever there. Features and sub-features. So about an article, you might have individual fields of that article. They're like a body. That's a feature. You need the body to exist in the new place. Then sub-features within the body of your content, you might have embeds of various sorts, structured data representations within that content as well that you need to consider how we express that. Talk to your stakeholders. This is the most interesting part that I'm continually surprised about. Me as a developer who's been with our company for a long time and previous companies for a long time, built most of the stuff that you see, I tend to think I know the features in my head. I know the entire outlay of my website. That is not true. There are all sorts of people who are using features of your website every day that to me might be bugs, but to them it's an important feature. And if that doesn't make it, somebody's getting a phone call. So, for instance, I've had two situations that I found interesting. One of them at a previous company, we're using Markdown. We have this, CMS WYSIWYG thing. People are clicking buttons, writing articles. We give them a basic toolbar of you can use these things. Here's your bold. Here's your whatever. Here's whatever else. We don't really expect them to go to the HTML mode. We expect them to use the WYSIWYG mode. And so we have two options for headings of things. At some point, I get some ping from Google saying you've got many H1s in all these pages. And of course, I'm trying to blame myself first. And it's like, oh man, well, I just refactored some of that. Maybe I got multiple H1s somehow. No, they were located very closely in the content well of these particular pieces of content. So I go looking around and I end up talking to one of these people whose content was affected. And they tell me like, oh yeah, I was using the H1 thing because like it looks so much better than the H2s and H3s. It's like, okay, who died and made you the designer of the like, just strange concepts that come out. But these people have a different experience than we do, and they need their needs met in various ways. And sometimes they find ways that go right around us, but they're important to support. And if you're considering that you don't have these tag types to consider in your migration, you might just be wrong. Also at Vogue, we ended up in WordPress as well having shortcodes for individual structured content items, embeds of various sorts. And one of them was for Instagram. And so you'd put a URL, we'd figure it out on the front end and say, cool, Instagram goes here, nice and structured, ready to migrate. At some point, we got pinged from them saying, hey, it doesn't work. And then, like a day or so later, they said, hey, don't worry about it. It's like, oh, cool, it fixed itself. Instagram's API went down. When you hear that back and forth with editors and such, it did not fix itself. They found a way around it. So we ended up with a lot of script tags directly in our content that we found at migration. So items like that, learn the features of your system. And I'd even suggest this isn't even migration related. Just do that frequently. There's people pushing buttons in your system that if they break, you get in trouble. Set expectations and commit to your error rates. So when we were done, I'll show you our actual initial pass error rates on our content in another slide. But we discussed ahead of time with our various stakeholders and said, hey, it's going to be impossible to get all of these over in a machine-based way. If you want the rest, you may have to pitch in some elbow grease to get them done. But setting those expectations, now when people come back to us and say, hey, this piece of content didn't make it to the migration, we get to go back and say, like, okay, it would take us a lot of extra effort to get all the edge cases figured out. And we agreed that this is now production responsibility. So it's really important to get that out there because that, again, will come back and bite you. Start your migration. So ideally, you start out with GraphQL. I'm going to discuss GraphQL a bit in this talk. I'm a huge proponent. We've had it in production at Vogue for almost 2 years now, which put us very, very early in that to a fault, but it's worked well, so good for us. But I'm happy that a few of the other presenters discussed a few of the core concepts, so I'm going to expect that you have at least listened yesterday, so I'm not going to hit the very basics. As you're fronting your data with GraphQL, it gives you a great opportunity for a lot of thinking, contemplation, other things. And the thing to think about is find your seams. As you start to represent data, where are your minimum dependencies? Where can you say, okay, we only have one linkage between this entire set of content and whatever else. Build a new front end against this data. So you have only fronted your existing data. Maybe that's a connection to a REST endpoint. Maybe that's a connection to a database directly. But you've just fronted it with GraphQL. You haven't migrated anything anywhere yet. Build your front end against that. You can work most of your stuff out, if that's going to be your final endpoint, pretty easily, actually. Release the front end, migrate the data. Sometimes there's updates necessary, and I'll go into a few of those specifically. And then simply rinse and repeat. Just keep doing that, and you'll be done. It's easy. So I did draw these boxes to prove my point. So they're non-representative of the real world, but hypothetically, you can see that getting GraphQL out there first allows you to parallelize your data migration and your front-end efforts. So that's kind of the big takeaway of this slide. So we know that there's some correlation between velocity and risk. I have found this wonderful chart that actually empirically proves it. So the general concept is be willing to make compromises. We did some things in some strategy and other things in a different strategy to get our overall velocity high while maintaining risk. And there's various ways to do this. Don't be hard-headed and commit to like we always have to do it exactly this way. Be willing to work with your developers. Be willing to work with your the rest of your staff interested in this. So consumers, what did we have? Well, basically we had this. A little bit of historical fiction here, but basically you can consider we had 2 iOS apps and we had this other website, and then we have this legacy website that we're trying to move off of entirely. Since this is WordPress and such, that is a website plus the actual data and such. It supplies pretty easily a REST API, which is occasionally invalid, but usually pretty useful. And then we have this other endpoint that we're trying to get to. So the very first step that we did, which I mentioned that last slide, is GraphQL in the middle. So you can see the ease now to some degree, especially when you have these iOS apps, things out in the marketplace that require other people, humans in the world, to update their stuff. We find that people don't only update about 80% within the first 2 days. So if those people are being forced to update, if it breaks in an unexpected way due to a migration effort, that's a bad experience. We want to try to avoid that. So we're building this new website. We had relay through the middle of all these things, another bleeding edge thing that was a little more questionable choice, but we made it and we went ahead. And then, yeah, we're abstracted, which is awesome. Talk about your entities. So basically your entities look something like this. You have content, you have media, you have collections. So collections are simply lists of things. Content, you might have articles. This is definitely a truncated list. This is just example items you might find in these categories. For us, clips are GIF format that's actually MP4, but kind of abstracting over that. It's just a clip. Don't worry about what it actually is. Collections include categories, are very popular ways to collect content. Author pages are pretty common, and then various forms of search also are pretty frequent. Articles look something like this as far as their dependency graph. You notice everything pretty well going out from the article, so the article needs all those other things to exist before the article is viable, you might say. So we did 2 approaches here. For contributors and categories, since those were simple enough types, just a couple fields really to each, we ended up migrating them all in one pass. We just took them all, sent them all over. The problem was we did that very early in our migration, so then we had to keep stuff in sync for a long time. We did a couple of approaches there. We kept some state on the old system so that we'd be able to know which items have not yet migrated. And then we also set up, in WordPress, through some hooks, we could see items as they're created or changed. And then as they are, we just pushed them right over. That worked pretty well. For the embedded content, you'll notice gallery is actually a prerequisite of article, and we followed that path. We built all of our galleries before we did any articles. Images, we found that in our old CMS that things lost a relationship to their media pretty frequently. Somebody would upload a new crop and never delete the old one. So we ended up actually doing, in true JavaScript experience, kind of a lazy compile idea. We did a lazy migration here. And so just as we found these images, we sent them over. Everything else was ahead of time. Images were, again, as found. So what that meant is as we were building our article content, we would come across an image, we would pause the article work, we would migrate that one fully end to end, come back with a reference, and then continue. So these are roughly our stats. I don't know what's competitive or not, so I just gave scale numbers, so 6 figures of media items and such. And so you'll notice the lack of migration happening in the media there. We only migrated about 55% of our media items, so that ended up being very useful because that was also the longest running aspect of migration. All of those bytes over the wire actually add up sometimes. So that was our initial error rate there with articles, 2.62% or so. And we continue to work on that in manual operation at this point. It was not enough to warrant additional engineering effort. We did some studies of the actual traffic as well. These are kind of what our sub-features look like. So this is the individual embeds that we might see in our content. Some of these need a backing entity of some sort. So an image, you need more fields, you need to store that a particular way. That has authorship, that has other stuff going on. A tweet is not necessarily that case. You could pre-render it or something, but in general, an ID to a tweet is useful enough. This is what one of our migrated things looked like from end to end. We built massive spreadsheets of all of these to say, okay, this is what we have today, this is what it needs to be. That also meant that we could build the front end against a known endpoint. We knew all of our encoding before we began, really. So yeah, there's a pull quote. Kind of cool. This is what our schema looks like. So you'll notice a pretty big content interface. Most of the fields that are useful to content display are there in that interface. Article and the other custom types sometimes add a few. Article here is adding featured gallery and body embeds. You wouldn't need either of those in a gallery itself. The gallery itself would be the featured gallery, so that doesn't make sense. You'll notice also I just found our contributor role mapping to be kind of interesting, so I included it here. Basically, a single contributor is not necessarily always a thing. They might be an author in this context, they might be an editor in that one, and a photographer in yet a third context. So that's not something intrinsic to their record, it is actually in the relationship between these things, and that's something we really discovered as we enumerated our content. So this is a Vogue homepage. I'm sure all of you visit this frequently, so it should be very familiar. So this displays 8 items, and this is a basic GraphQL query. So this is just showing, I've truncated a little bit so that it makes sense, query and response actually. So yeah, we just request on the content interface, and that's very important. We'll come back to that one. We request these different fields, we get the fields, we display some content, everyone's happy. You'll notice though that we're specifying all these individual types. That was our initial approach to this, and that was a bad idea. Don't do that. So we actually just take it off. We apply a default set of types on the server. You can supply them if you really only want those types, but if we let the server do it, there's some magic we can do. GraphQL specific considerations, again, you release your collections pages first. Otherwise, you're going to lose discoverability. If you move all of your content in one category, articles for instance, from point A to point B, but various collection pages are still fronted by the old environment, or I guess backed by the old environment, then you can't find that content. You don't have it on your homepage, you don't have it on search pages, authors, people get mad at you, even though nobody enters through front doors of content websites any longer, but still, something you have to do. So make sure your collections are out first. Migrate all the dependent data types. Again, for me, those primarily contributors and categories. Build new types for the content. Don't replace it inline, build a new type for it. We have article, now we have article X, Copilot in our case. And you can actually deploy your schema change to production. As soon as I learned that, it blew everybody's minds, and then we all thought about it for a minute and said, oh yeah, of course, we can just add a new schema. It doesn't need to be filled, it doesn't need to be used. That was critical. Then you have to be able to resolve double merge stuff together. So that list that I showed you of 8 items, we used to just go to one backend and say, give me 8 items. Now we go to 2 backends and say, give me 8 items with these various filters, what have you. We merge them together, apply a sort again, truncate that back down to the number that was requested. So then we can represent from both sources. For us, we do a lot of joining on slug because we don't necessarily know that the same entity is in the same place by ID or something else. Push your fragments out first. If you needed fragments, which are how you resolve specific content types, get those to the front end. There's no reason not to. Then you can go live. At this point, you can decide if you want to replace the content in the old entity. So we had article, now we have article Copilot. How do we want article to act now? Do we want it to keep pointing at the old stuff? Do we want to replace it? We could just fill those entities with the new data as well. We elected not to by the time we were done. It was just extra work, and we were able to get people to the new content type without that effort. So this is kind of visually how you would go through this. So query post is a WordPress function that is fun. I'm sure some of you have seen it before. We're just going to talk about a term page here. So it's resolving articles, galleries, and probably other stuff. And some of those have relationships, right? Pretty simple. So we're going to replace that with a GraphQL query. We also replaced the front end here, hypothetically, and we've now built our new content item. This is article Copilot in our case. So we've stood that up all alongside, pretty seamless. We launched a new front end. We're dealing with front end bugs, but we're not dealing with any of the other bugs. We don't have to worry about the migration bugs yet. Now we build a merger. So this guy is able to pull data from different sources. Doesn't matter if it's on the same endpoint, different endpoints, we're able to pull it all together. Then when we're actually ready to migrate, all this while we can be filling our other content type, we can be testing it in various environments. Then when we're ready to go live, we can just switch over, and now we are pulling from a merged environment. So this was our content query again, right? And it was very important that we didn't specify stuff directly. That means that now we can resolve all the fields that we need off of the core type, and we can also not have to change. We have default resolvers or default content types specified on the server. It's much easier to change stuff on the server than in all your disparate clients. So we go from this. This was our initial spread of things. So we have, our old environment to the top. WP stands for WordPress, in case that's useful. Copilot is the next one. Then, very simply, we move stuff over, deploy it, and we have now migrated. That was really our main migration step right there. So that was mind-blowing. Some cases we had to do this as well, and that's swapping out a fragment. So that one's pretty straightforward as well. Very few instances in which that really mattered. And so in that case, say we're done. High five, etc. Favorite GIF, one more time. There we go. All right. So let's recap this again. So enumeration is incredibly important. Figure out what your consumers look like, what shapes they are, how you can affect them, update them, get them ready for this change. Figure out all of your entities. What needs to be fronted? Can you trim any of it down? Do you still need all these features? Think about these features, sub-features. Talk to your stakeholders. See if there's any features of your website that you don't know about. You want to avoid fundamental surprise. When you go live with this thing and somebody comes to you 2 days later or a month later and something has been broken in a very important way to somebody very important for a month, that's really bad. You want to find that at the outset. Set your expectations, get people to agree on certain error percentages that everyone's comfortable with, model that out, figure out what the lost revenue or lost traffic or whatever else would be, figure out various mitigation strategies for those. Now migrate. So again, stick some abstraction tier in the front. GraphQL was incredibly useful to us, but I think you could probably get 80% there with many other languages. So it's not a hard push, but I would recommend going to 100%, so that requires GraphQL. As you're building your schemas, think about where your seams are. Figure out how you can separate the data and how you can represent it various ways. Figure out what your minimum viable blocks of migration are. Sometimes it's a pretty big block. Sometimes it's smaller and more contained. Release this new front end, migrate your data. If necessary, maybe there's some fragment updates. Hopefully not, if you've built really good interfaces. Hypothetically, you could actually build also, say, an article interface on top of that that's even more specific and implemented by both your old and your new content type, hypothetically. And then, yeah, rinse and repeat, and you're done. So at some point, one of you, all of you, will likely migrate again. So I have to say, good luck.
You got 5 minutes of Q&A if you want.
Great. Who has questions about migration? Or GraphQL?
Well, about both. It seems like one of the key insights you had was that you could push out the schema part early.
Yes.
And I have a feeling you're telling me you wish you'd done that a little bit earlier in the process. When would you recommend that we look at, because none of those steps was explicitly talked about, create the new schema or define the new schema. But when would you do that?
Yeah, so one of the slides I snuck that in. Maybe it wasn't well called out. It was the GraphQL considerations one. I said build a new content type. But yes, it depends if GraphQL is new to you. So GraphQL was not fully new to us. We actually built it in an earlier phase to support one of those apps that we were launching. We knew we would be migrating in the future, and so we did it a little bit proactively. So we had a little bit of GraphQL experience by the time that we got there, and we're pretty well able to handle the situation. Yeah, but as early as you can. I mean, if you have the dev resources to spend on it, you learn things when you have to describe your data. You learn a lot of things, so as early as you can.
You were tracking error rates. Is that bugs coming in, or?
So how did I define error rates? That one, I was very aggressive on the back end. So we migrated from WordPress to Copilot, and we did so statefully per se. We recorded the state of the items as they moved. And that was really useful to connect various items in various places. So again, we could actually push an image over, and then we could use it in the article migration. So in that case, what we ended up doing is, for articles, why it was specifically so high, is after I applied all of my transformations, if I found any leftover HTML, I would fail. And so the concept there was then we needed manual intervention, figure it out. If we find patterns, we can do another transformation to it. But I wanted to be super conservative because most of the times you look at websites with old content and you just find gibberish on there, and I really wanted to avoid that. I'd almost prefer a 404, and we were able to at least have those conversations then.
When you're doing your migration, you find opportunities to improve the structure of your data. You think it would actually be helpful or to be organized. Do you see the migration as an opportunity to do that, or shy away from doing those two things together?
Right, so do you use migration as a chance to be able to reformat your data, or do you go with what you got exactly straight? We did a little bit of both. We had a pretty clean taxonomy before, and to the point of we left a lot of images behind due to just following relationships rather than doing a kind of an all-at-once approach. So we did a little bit of that. We wrote our initial, the old data description closer to the new data description than was immediately obvious. So we didn't copy a field name from WordPress because in most of our cases, we actually preferred the new field name, and then it made the transition and translation easier. So a little bit of both. I certainly wouldn't bike shed too much on a full cleanup while doing this other stuff. But yeah, the cleaner you can start with your data, the fewer errors you'll have on the other side.
Let's take one more question if there is one. All right, well, thanks again. Okay, so we're going to get set up for the last speaker. It's going to take a little bit of time because there's extra hardware involved. I have to duck out a little bit early, so Andrew's going to do our closing remarks. So I want to take this opportunity to thank all of you for making this event a huge success. So give yourselves a round of applause. And then Andrew over there will be closing us out. I know he's not going to say this, but Andrew's really the brains behind this operation. He and I are the two main people at Wayfair who are putting on this conference, but he did the lion's share of the work, especially over the last few weeks. I had a baby 2.5 weeks ago, and I've done basically nothing for this event over the final stretch. So it's all Andrew. All the details, all like the badge stuff. Yeah, please give him. Yeah. Yeah. This event literally would not have happened without his help. I also just want to quickly thank Marissa and Michelle, who are from Ramel Productions. They helped us put this event on, did an awesome job as well. So, yeah. With that, hopefully we are pretty close to taking flight. You like it? This is going to be awesome.
Wait, don't connect yet. Hey, what's going on? Hi guys, excited to be here. Couple of seconds, I connect everything.
All right, take it away, Vladimir. I'm out. See you guys.
Yeah, all right. So, yeah. Hi there. Today we'll be piloting a drone with React IoT. A bit about myself. My name is Lara Novick. I work as a software engineer, software architect, and senior consultant at Code Value, based in Israel. I do lots of stuff in web, mobile, IoT, mixed reality, and virtual reality fields. And I'm also an author of React Native Building Mobile Apps with JavaScript Vogue, which I released 3 weeks ago, probably 4 weeks ago. And today you will be getting one. So tweet React Boston, Vladimir Novick, and book raffle, and one of you will get this printed book. So yeah, you're in talk. So we will start with history. We'll start with history of drones. Somebody of you know when was the first drone? Yeah? 1898. Yeah, Nikola Tesla basically did an exhibition in Madison Square Garden where he showed a boat which was controlled by voice. He was differentiating frequencies, and based on frequency he could control drones. So basically he had the first voice controlled drone, right? Then in First World War, there was they were launching drones on catapult and then controlling with remote controls. Not really scalable, I think, but yeah, it worked. It worked in the war. So then in 40s, actor and hobbyist Reginald Dennis sold 15,000 radio control target drones to U.S. military. By the way, it goes on, right? The whole history thing. And then in 82, there was a war between Israel and Syria, and Israel deployed lots of reconnaissance drones. We basically lured Syrians' aircrafts and missiles to know where was the exact location of the basically of the enemy. And 1995, there was the General Atomics MQ-1 Predator UAV, which entered service, and probably you've heard about that. 2010. Well, 2010, there was the first consumer drone, and that was probably, a company called Parrot drones. You've probably seen lots of ads about that. I actually have the Parrot drone here, so we'll fly it. And from basically developing of this drone, the whole age of consumer drone began. And so much people use this drone, so that in 2012, FAA decided to integrate small drones into national airspace. There was decision made, and by 2015 it happened, but it was the past, right? So what happens now? What's going on with the drones today? Today, have drones in retail, right? We have Amazon Air and drones flying around and a bunch of people shooting them, right? But hey, it's Christmas presents, it's good, yeah. We have lots of people making this kind of DIY drones from Arduinos, Raspberry Pis, lots of motors, spare parts and stuff like that. No, my drone is commercial one. But I have the remote control, which is, I don't know how I passed security to bring it here, but you'll see. Yeah. Yeah, it was crazy. And we have military drones. Well, at some point, the military will come back. Yeah. Yeah, or maybe in this form. What it has to do with JavaScript, right? We have lots of drones. Most of robots or drones are programmed with Arduinos, which is basically Arduino language, and what we can do with JavaScript with these drones. If you didn't know, JavaScript is everywhere, right? So basically, it's on servers, it's on databases, browsers, cloud, and it's on physical devices. You can actually run JavaScript on Arduinos, you can run JavaScript on Pis, you can run basically Node. When you run Node, it runs everywhere, right? And React is also everywhere, and if you don't know this picture, it's from the TV show Westworld, and you can see here is React Create class somewhere. Yeah, if you, here, it's right there, you have a React Create class. So assuming Westworld is not Facebook, but hey, they don't have patent clause now, so everything is good, right? JavaScript everywhere, React, moves everywhere. We have Internet of Things, right? We have smart homes, we have smart devices, light bulbs, you name it. And at some point, when connection is down, and the refrigerator don't want to speak to stoves, or your lights turn off, you need to go out eventually. But all this like hilarious thing bring me to one point. There is a framework called Johnny 5. This is like huge framework and the whole community called Nodebots behind it, and it basically gives you an ability to write JavaScript on various sets of boards and basically do everything you would have done with like Arduino language or in Python or other languages, and it looks like this. For example, I have a board and I want to light a LED on the board, so I import board and LED from Johnny 5. I create new board, and when my board is ready, I just create new LED, and I set GPIO pin to be 13 for Arduino. For other boards, it will be different. For example, for Raspberry Pi, it will be prefixed with Pi 1 dash. For Tesla, it will be different. And then I want my LED to blink, so I just say LED blink, and it just works. So it's amazing, right? So Johnny 5 supports different things. It don't support only buttons. It supports different sensors, controllers, joysticks, LCDs, lots of stuff. You can go to Johnny 5 website and like spend hours in its API, finding yourself after a while on Amazon, like purchasing like crazy these boards and these electronic things, because it's really awesome. So I decided like to take Johnny 5, which is kind of standard, take React, and try to combine them. Like if you see it here, the syntax is imperative, right? You say board, this is pin, this is LED, it's supposed to blink, right? You say blink. I want the syntax to be declarative like we used to in React, right? So I combine them inside something that's called React IoT, and it's library available on NPM. You can use it, and we will use it now for like several examples. So why basically it was done? React ecosystem, as I said, used everywhere. Declarative versus imperative is much better. It's much better to set your state of the LED to be true or false, and when the state changes, automatically your LED lights up. Using React way of thinking, like composing components, right, it's a hardware. It's not like there is a device that won't be there after a while. It's like not really a tree structure, but it gives you the ability to think like composing different boards, composing different like sets of behaviors on the same board. And it also gives you the ability to be portable from taking a web app and taking the same code you wrote for a web app with regular React, and just take the same code, run it on Raspberry Pi, on Arduino, stuff like that. It will just work. And it's fun. It was fun to create it, fun to fly drones, fun to get past security. Yeah, and actually I took everything apart and combined them in my hotel room. So I put like a sign, "Don't disturb," because if the room service will be getting into my room, I will be probably taken to FBI or CIA, or I don't know. Yeah. So let's pilot some stuff, some drones. Okay, I have this drone over here, and I will start it, and it will start blinking, meaning it's trying to pair. And then I have here like a server. We will see. We will take a look at the code in a bit, and hopefully it will connect. If it not, I will just reset. No, it connects. So you see, it stopped blinking, right? If I go back to my web app, I see it lights, right? The tiny LED. Now let's fly. I hope I won't kill anybody, right? Okay, I will probably land. Yeah, so this is like, so this is a web app, right? And the web app that controls the drone, and probably you here you really want to see the code, right? So let's see the code. Let's start with the client. Basically, there is a node server. You've seen I started, like type 10 p.m. start, and then node server starts, and there is a client. Client you've seen over here is this controller. So I have like a bunch of styles, and I have my state, which has like two keys connected, false, in error, false, right? Connected is for like the actual connection to display the actual LED, the red button, red thingy you've seen, and in error is used to change the button from take off to land. Then when my component mounts, I connect a socket IO client, which is my node server, and when it's connected, I basically set my connected state to true, and it leads the LED, right? So when my drone takes off, I receive event from the server, right? When the actual drone takes off, I receive that it did take off, and I change in error to true to toggle the button. When signal is low, I just pretend that it's okay, and then it's like it's landed or something like that. And signal is always low. This is an issue. Yeah, and also if it did land, so in error false, meaning we have like takeoff button, right? And change state, take off or land. And regular, you don't see anything like different here, like it's a regular React, right? The really easy state changes and a bunch of styles and like a button. If I hold the button, I move left. Because of how drone works, I put an interval every 100 milliseconds and emit events move left, move left, move left, because drone, that's how it works, unfortunately. But so it's hacky, but okay, it worked. And when I release the button, then I clear my interval. This is how it's done. Move, common direction, interval, and stuff like that, right? So that's the client side, right? And the server side is really simple too. It's like basic express HTTP socket IO drone. When I have a connection, I emit connected. When my drone take off, I emit things with a bunch of console logs for debugging. When it lands, I basically emit that it did land, and when it moves, I I basically use drone.move. When using drone here, I use node rolling spider, node rolling spider library, which is a library for these types of drones. It's for this one. This is Mambo drone, parrot Mambo drone, and for another one, which is Mambo rolling, parrot rolling spider. It uses the same characteristic and same services in it uses Bluetooth Low Energy and same services and characteristics, so it's fine to use like for both drones. But this drone has like extensions here, so it's something that I'm working on, like reverse engineering the thing and adding like a bunch of functionality, like it can actually be can have mounted cannon here. So yeah, yeah. So this is like the regular React, right? So now we want to port everything to device, and we'll hope that everything will work. So basically, to port this to device, what do I want? I want like the same server, right? No changes from the server. So server code basically stays. Client's side code cannot be with divs and buttons, right? It's supposed to it's supposed to change things. So it's I change it to meet React IoT requirements, which we'll see in a second. And ISCP both to Raspberry Pi and just run it, hoping that it will work. So let's take a look at the code, and then we will try to fly the thing. This the client code transformation. That is the most important one. We have React. We have Raspi from Raspi. Every board except Arduino need to be configured in Journey 5, not especially in React IoT, in Journey 5. It needs to be configured with several plugins. These plugins basically define the API how Journey 5 will work with actual device. For Raspberry Pi, the plugin is Raspi.io. For Tessel is T2.io, I think. And there are a bunch of boards. All this thing is written in Journey 5 documentation, so you can just find it there. And then I take React IoT from my library, board, LED, button, and container. I thought about making it Vue, and probably I will, to make it more look like React Native, but we'll see. Maybe I'll do it. So I have the same code. You see, it's state, connected, false, and error, false, the same. Component did mount, haven't changed anything. The code stays, my logic stays, right? And then when basically the drone takes off in L2, same code, right? I don't know why I stopped on it. Now this is the major change. We don't have divs anymore. We have container, we have the same checking if state connected, and we have LED with probe pin P1 13 is on, getting Boolean, which is basically the thing I wanted to achieve, right? When I changed the state, I wanted it to to render the component, but I don't have the component on the board. It's the physical LED, right? So under the hood, it's calling the imperative API to make this LED on or off or blink or whatever. And then I have a bunch of containers there. Container is used mostly because we don't have trees here. The whole structure is flat. But if you wrote your UI using divs and nesting, you want to keep it. You don't want to refactor thing. You want to take the same code and refactor little bits, making divs to be containers, LEDs, divs with style of LED to be actual LED. So container is basically empty component that just returns children. So it's nothing there. So it's only for convenience. And the button basically can get all props that Journey 5 can get. So if Journey 5, you do a new button with config, right? As I showed you in one of the first slides. In the config, you can pass the actual pin, you can pass several parameters. So basically, it can support any parameter from Journey 5 API. So you can name is just for naming. It doesn't do anything. Just see what this button does. Is pull up is the actual. There are several types of buttons, buttons that you hold, button that you hold and release. The several types, all described in Journey 5 docs, API docs. So when you press down, basically the same logic I had on mouse. Mouse up, mouse down, right? So on down, on up. I can pass here on press, and then it will be similar to on click. I can pass here on hold, and it means I'm holding the button for several seconds. So basically support everything Journey 5 supports. And this is the move command, so yeah. So it's doing the same, it emits command and direction as it did in web app, and this is the takeoff button. Yeah, it's the takeoff button. And in the end, in order to render it, I have to call React IoT render, and I have to wrap my application in board, right? In Journey 5, you have you can pass one board, you can pass several boards, you can pass an array of boards, stuff like that. That is not yet supported, but it's on our roadmap. Currently, the library supports passing one board and different things inside the board. but you have to like wrap things inside the ball. Can we talk about context? So yeah, it abuses context too. So probably we'll have to change it when context will be out. But yeah. Yeah, now on device. That's a webcam. Yeah. Let's take a look on the actual device. Now you can understand why security. I was concerned about security, right? Don't worry, it won't blow. Okay, so let's do that thing. So basically, I have buttons here. This is pull-up buttons. This is a bridge that's bridging to. This is Raspberry Pi. Okay, bridges to Raspberry Pi. Raspberry Pi connected to like power source. Okay, it's weird to do this like this. Okay, so now what we will do, we will stop our server here, and we will get, let's see, yeah, we'll start server on Raspberry Pi, and we will really hope that it will work. Takes time, huh? Connecting, start listening. Yeah, cool, it's connected. So now I will run my library, like the client code I showed you. I pray to demo God, yeah, so I hope.
Is your other server also running?
No, I stopped it. Yeah, so there are a bunch of like logs here of, from inside render. I have to remove that. But let me show you. Don't worry. Yeah. So you see the LED here, right? It's the same LED we had. So it's like it changed its state. Yeah, and come back and land. Yeah, thanks. So I think it's probably awesome flying drones. But let's talk what's under the hood. You've seen here like a bunch of things, right? Like get root, host context, prepare for commit, reset after commit. So you can probably understand that it's custom React Fiber renderer. It uses, it disables lots of things because I don't need any changes in text nodes. I don't need, like most of the things I don't need, but I